esteemed guest for today's webinar, Professor Sardar M.N. Islam. Known fondly as NAS, Professor Islam is currently serving as a professor at Victoria University in Australia. His impressive academic journey includes a role as Distinguished Visiting Professor of Artificial Intelligence at Unsuri and as a Distinguished Visiting Professor at ORAC from 2019 to 2021. He also holds the position of Adjunct Professor of IT and Business at the Armstrong Institute at Melbourne and is the Editor-in-Chief of the International Transactions on Artificial Intelligence. Professor Islam is renowned for his global and humanistic approach to research and academia. His work spans rigorous scientific studies in computer science and various other disciplines, garnering international acclaim. His contribution have earned him numerous honors and awards, multiple visiting or adjunct professional appointments worldwide, and significant editorial roles in prestigious journals. He is also a highly sought-after keynote speaker at international conferences. A prolific author, Professor Islam has published 31 scholarly authored academic books and 4 edited books with prestigious international publishers, contributing significantly to the literature in various disciplines, including computer science. His publications are highly regarded, with many appearing in his esteemed book series. Additionally, he has authored approximately 250 articles, including leading international journal articles in his specialized research areas. Please join in welcoming Professor Sardar M.N. Islam. Professor.
Thank you, ladies and gentlemen. So, can you see my PowerPoint?
Yeah, we can, but you have to put it on slideshow, I think.
Slideshow, okay. Now I'm putting slideshow. Okay, so that is the title of the talk: Artificial Intelligence, Machine Learning for Intelligent Asset Management and Automation. Classical and quantum computing perspectives. So that's the topic I have been introduced. So, to start the talk, because the talk will have a fair bit of focus on quantum computing, which is the most important thing in the current world. Many of you probably have seen, but just to show how the quantum computers look, and also how important is quantum computing in the current world. And we'll talk that later. Just to I just give just some photo here. So the structure of the talk, my presentation, I will still just briefly introduce the topic and then briefly the concept of asset management and artificial intelligence, and then also discuss quantum computing, and then how to use classical computing, especially machine learning and artificial intelligence in asset management, and then how quantum computing can be used in asset management, and what is the importance of this topic, or the integration of artificial intelligence, machine learning, and quantum computing in asset management, why we need to use these techniques, and what is the future directions, and then conclusion of the talk, and then the thought that what is the importance of using technologies in all areas of human activities, especially in asset management. and what are the opportunities for work, enhancing, improving the world and career, and contributing the profession. What are the opportunities? I will just make some brief comments and then question and answer. So, this presentation is a discussion of how artificial intelligence and machine learning are being utilized in the area of asset management, from conventional methods to cutting-edge application of quantum computing. And the purpose of this talk is to educate, inform, or inspire stakeholders, all type of stakeholders, academic, consultants, industries, policymakers about the future of asset management technologies and the opportunities for collaboration in consultancy work of publication, for improving the discipline, but also enhancing business economy and also broadly the operations of industries and technologies. Asset management, I think everybody here is familiar with the concept, but just to introduce it to as a set of background, my talk is asset management is managing physical asset, machinery, building, etc., maximize value and invest over their lifetime. Principles of asset management, life cycle management, risk management, cost-benefit analysis, strategic asset management planning, and the methods commonly used are predictive maintenance, asset health monitoring, resource allocation, performance management. And then role of digitalization in asset management. As we know, maybe 20 years ago, all the asset management activities were being done on the, hard copies, hard paper, journals, notebooks, but now things have changed. Now we are using digital technologies to do many of the asset management activities, planning side, operation side, maintenance side, prediction side. So as you know, digitalization is taking place in all our activities. Like currently I'm giving this talk is also an evidence of the application of digitalization. So this digitalization is also taking place in the area of asset management, using different forms of technologies to do planning, to maintain, and to operate, and keep a record and predict the asset management activities and operations. Information technologies are being used extensively now. So what are the benefits? The benefits is that it helps asset management systems operations to be automated. Automation has many benefits, such as increasing efficiency, improved accuracy, enhanced decision making, reducing cost, reducing time, and all that sort of things. And then, therefore, the pace of digitalization in asset management is very high, rapid. And what are the tools we use? We use different computer and information technologies. Some of these things broadly we can call embedded computing. Embedded computing means that we use develop an artificial intelligence algorithm or machine learning algorithm or computer program that we include in a chip, computer chip, and we put that chip in an asset. So this chip can give information about their operation, their condition, when it requires maintenance, whether it is functioning efficiently or not, or if there is any accident, it will inform us immediately. So this immediate computing is the main approach to adopt in the digitalization in asset management. So all sort of assets we can use computer chips. Like for example, in our fridge, in our television, we have computer chips. So these chips, can help us to use remote control or the fridge to give light and so on. Similarly, we can include chips that also helps to manage those assets, including fridge, television, also in a efficient form, giving us information how it's going, whether we need any maintenance, or when it should be replaced, and so on. So these many of these assets are also connected through IoT devices, so that each asset can connect and communicate with other assets. And these are often operated through cloud computing, not through any other internet. Cloud computing is to be more platform independent. And in this process, we also use the big data, not only the data from this assets, but also data from the internet, and we can make them real-time data streaming for all those application of digital techniques. So we are talking that we are using artificial intelligence and machine learning. So briefly, many of us, we are familiar with the concept artificial intelligence. Just briefly to mention that what is artificial intelligence. We know, many of us, but sometimes we not be very 100% clear what is it. And so essentially, artificial intelligence is a computer program, a computer algorithm and a computer software. We write a program that helps machine to work like human beings or natural beings to perform tasks, think, understand, feel, and sense. So this is what we call machine learning. So machine learning is the applied side of artificial intelligence. We achieve artificial intelligence through machine learning. So in this area, asset management, we can use this machine learning and also data science, data analytics, and develop some portals or software that will help us to manage assets efficiently, properly. And in this area, the main task that it involves the use of mathematics, especially statistics and operation research computer programs, to develop machines or computers to be able to develop artificial intelligence to do think, perform tasks, and so on. And broadly, we have discussed before the purpose of this digitalization, using artificial intelligence to automate things, make them more efficient, and also many things possible which are not possible by human being in all areas of life and living. So the so we as I said, we have in computing. Now there are two different types of computers. One is the classical computers, that means the normal computers, like the computers that currently we are using. We call them classical computing or classical computers. So for asset management, we can use our normal computers to apply artificial intelligence in machine learning for asset management. So how we do? As I said, I said before, we develop a computer program, and then which is artificial intelligence, or we can also say machine learning, and then by using our current computers, and then we put that in a chip, and then we put that chip either in the assets and also connect them through our computers or IoT, Internet of Things, and possibly through cloud. So some of the technologies and algorithms that are commonly are used in this area: neural networks, decision trees, support vector machines, and we can also use other form of advanced machine learning algorithms. And so what are the uses? So predictive maintenance, to give us the information when an asset should be maintained. We need to require some maintenance, cleaning or replacement of parts, or to anomaly detection, like whether a machine is working properly or not, an asset is working properly or not, whether there is some problem that needs to be fixed. And demand forecasting, for example, how many assets will be needed for a company, or for even for the economy or for an organization. This sort of demand forecasting, or production planning, and also broadly also for automation of asset management operations and activities. And how we do it we use different computer programs. Two very popular programs, recent more emerging ones, are Python and R, for the development of this machine learning to achieve artificial intelligence. And in Python is very popular, and we can use actually Python very conveniently. In Python, we have different libraries like TensorFlow, PyTorch, and scikit-learn, which can be used very conveniently. So we don't have to really learn 1,000 lines of coding. We just use the libraries and connect them through maybe 10, 20 other commands in Python development frameworks. And now the world is changing, and the world is changing and will be changing very substantially. Those who we are following what is happening to the world human being will also know. Those who we are a bit familiar with the futuristic developments for the world, the universe, and human being, they will be following, especially physicists and engineers, or even common people, that the world is changing. Things are changing very fast. Initially, a few years ago, it was because of artificial intelligence, but in recent years, the most profound force to change the world, even the universe or human being, is quantum computing. So the quantum computing is considered to be the most important invention by human beings. How is, I just briefly say, because as human beings, we need to understand what is happening to us in the future. So the quantum computing is changing the whole world. And so quantum computing, therefore, is also going to affect all areas of human life. And therefore, quantum computing is also being used and will be used extensively also for asset management, because quantum computing can actually give the best form of asset management performance. So I will briefly say what is quantum computing, and also why we use quantum computing, because the quantum computing can compute many things that normal computers cannot compute, because the normal computers cannot really simulate the real world so perfectly that quantum computers can do. and quantum computers can handle many complex operations optimization and can do very advanced simulation of complex systems and can give a better automation and so on. So from operational side, for getting better asset management, we need to certainly use quantum computing as soon as possible. And some of the computing that will be used are listed here, but I will just mention them again. So, as I said, quantum computing has come. If you see people around the world, especially now, countries in the world are competing for what? They are competing to be leader in the area of quantum computing. In many countries, in all countries, you can see the quantum computing is receiving, highest amount of government research funding in the area of quantum computing. Same is the case in India. Indian government allocation for quantum computing, I think, is 500 million US dollar. And that is also very big amount in also America, Australia, and other countries also. Therefore, because the quantum computer is better than current computers, this phenomena is called quantum supremacy. One example, last year, Google did quantum computing, use quantum computers to compute a mathematical problem. It took them about 2 minutes. And you can see their website, they claim that if we use classical supercomputers, that will take, to do the same computation, it will take 10,000 years. So not only that, the quantum physicists, they predict or they claim that when there will be a full-fledged quantum computer, the quantum computer will be able to compute things that classical computers will take life of the universe. So that means infinite years that will never be able to compute. Therefore, we need to use quantum computing in asset management also. So with the quantum computing is a new way of doing computer developing technologies, and this quantum computing is based on three pillars. One is quantum theory, second technology, and third is the mathematics. The classical current computers are based on the based on Newtonian physics, the normal physics, open eyes physics that we see or we study and learn. But quantum computing principles, algorithm technologies, and ideas are based on quantum theory. So quantum theory is coming from quantum physics. So there are some very strange principles of quantum physics or quantum theory. And this quantum theory and physics, they deal with particles or phenomena at the atomic level, subatomic level, not within atom, at atomic level. So in the atomic environment, they said that things can exist, particles can exist at different places simultaneously at the same time. One thing can exist in different places, and one particle can be entanglement. That means one can get entangled with other particle at the same time, and things are all uncertain there. within atom until we measure, and then we can see what is the probability of existence of something there. And so the quantum physics, is quantum physics is probably is the most difficult subject in that we have in the current world, and is has been the most controversial discipline for about 100 years. And so on the basis of the other aspects of quantum computing is the quantum technology. Like in current computer, we use we call it bits, like 0 and 1. That's why we call it digital. But the quantum bits are not digital. Quantum computers are not digital computers. They are analog computers. And in quantum computing, the basic unit of cooperation of information is qubits. And then we use qubits passing through quantum gates and then develop algorithm, then we get the results. And to do that, we develop different circuits like the normal circuits. But also quantum mathematics, quantum computing, quantum physics is very mathematical topic. It has uses very advanced mathematics, including there is a special branch of mathematics. We call it quantum mathematics also. By combining these three areas, we can develop quantum algorithms, and the quantum computers are being developed, and then we can use quantum computers based on this three foundations that can be used for doing calculations and programming, and also can be used for asset management. So we have discussed these issues before. So in the some of the other technical aspects, I will not go into detail, but it just to know that if people are interested to know, they need to understand the foundations of quantum computing. I will not go into detail of more these technical things. One thing is that in classical computers, like the computers that we are currently using, the technology, the hardware is the uniform, one type of, but in quantum computing, there are actually different type of hardwares and computing approaches. So quantum computing is still a bit complicated things, but things are progressing very fast. And there are different algorithms which can be used in quantum computers. And if we want to use quantum computing for asset management, we have to use algorithms like this algorithm, which are listed here. And one thing is that in the current state of quantum computers, quantum computing gives some errors because at the sub-atom level, within atom, particles are very sensitive to the outside world in noise. So therefore, quantum computers may give some errors, but there are some codes which have been developed to check whether there are errors, and that can be also corrected. So some of the quantum programming languages and tools that are currently being used in different areas and which can be also used for asset management. Like quantum programming is also completely different from the programming that we do on the classical computer. So we have to learn new way of doing programming on quantum computers. And some of the computing environment or computing programs are developed by Qiskit is owned by IBM, Spark by Google, Q2 by another Quantum 2 box, and Penny Lane, also another computer program which is used very extensively for quantum machine learning. So developing code program that can be used for asset management, we can use this sort of computer programs. There are many, applications of quantum in different areas. We will not go into detail of those. But quantum computing is actually being used or in the process of being used in almost all areas of human activities, from business, finance, optimization method, health, material science, energy, manufacturing, transport, and also certainly asset management. And just a brief comment on something that may be of interest to many of us is that quantum computer or quantum physics actually gives a different interpretation or different perspective of human life. What is universe, where the universe came from, or what we are human beings, or where we came from, where will we go, and what is going to happen to human being in the future. So it's a complete philosophy. If somebody interested to know what the quantum physics is saying about the world, the earth, the human being, human life, and so on, then can read some books in that area, some other materials. So some of the things this quantum theory and quantum computing are saying are very bizarre. They are very counterintuitive. Some of the things they say that the quantum physicists, they claim that the world, even our body, our brain, we are just quantum computers, because the world operates like a quantum computer based on the principles of quantum theory that we have discussed before. Essentially, human being is a quantum computer because the current digital computers, they operate through 0 and 1. They are digital numbers, but the world operates on, on particles, atoms. So quantum computers can simulate the world, or the world simulates the quantum computer. So, and another interesting thing, they say multiverse. So, it's briefly, it will be, it's interesting to know what they say. They say that there are many universes, like in our normal physics or knowledge or our belief traditional, we think there is only one universe, including the solar system and galaxy and other things that we have studied in physics. But quantum physicists, they said that there are many other universes. So they said that it is possible that the current seminar is being held in many other universes. They said there are many other universes, millions. So you can see if there are many other universes. So what is the universe, or what is the situation we live? And then the quantum physics that one day the human being will not really live on this earth. They will move to other better places in the space somewhere. Maybe other. It's possible to the quantum computer. They say that quantum computer can be used to teleportation human being to the universe within a few seconds. There are theoretically possible, but they claim that is also possible practically. And most confusing hypothesis of quantum physics and quantum theory is immortality. They said that human beings, soon quantum computers will be able to make human beings and all other animals immortal, so they will never die. So you can see that these are not my philosophy. These are some of the most important hypotheses or theoretical prediction or claims of quantum physics and quantum computing. In any way, so quantum computing will certainly, on the application side, quantum computers and quantum technologies will certainly be applied and adopted in all areas of human activities, which is happening, and it will keep on happening at a very rapid speed, because there are many benefits: improved efficiency, productivity, convenience, support for all areas of life and living. So we need to use quantum computing and also quantum related or even classical artificial intelligence and machine learning to do enhance asset management, planning, implementation, operation, prediction, maintenance, and so on. So this is urgent, and the one thing is that quantum computing and artificial intelligence can be combined together. So we can do artificial intelligence on quantum computing. So, these are the changes happening. So what is of the future of mankind and the world? So we have to think, we are human beings. The artificial intelligence is going to change the world. There are different things, and we have seen what are the quantum supremacy quantum computers are saying. So what will happen to the world? Then many people, they just say that we are living in a science fiction world. So we don't know what will happen to the human being and the world in the future. So my understanding, given on the knowledge I have, what will happen to human being or to the world, to the earth, nobody knows. In any way, so there are many risks of artificial intelligence, but also quantum computing. But they also give a lot of benefit. And then the focus of this talk is that we can integrate quantum computing in asset management. And then by combining quantum computing with artificial intelligence, we can learn enhanced learning. Machine can learn better to perform things. Machine can learn better prediction. A machine can do maintenance work better, because many of the things can be automated. The maintenance can be maintenance of assets can be also done automatically by programmed embedded in assets through combined artificial intelligence, and but now it combined in quantum computers. And there are still some challenges, but the progress, the future direction is in that area. And if we use quantum computing or artificial intelligence, or combine quantum computing and artificial intelligence together, that will certainly revolutionize the fundamentally change or transform the discipline or practice of asset management. So this is a good area, a very important area for many reasons, and just to know the world we are living, to contribute to this emerging discipline, and certainly to enhance the discipline of asset management, and at the personal professional level, this is a good area for doing better world, better industry, better asset management, but also doing better academic or professional work, especially at the personal level, career level, doing consultancy work or research projects and international collaborations for opportunities, and especially young academics. This is a good area where people can apply artificial intelligence, machine learning, and especially now combined with quantum computing, or it's a quantum artificial intelligence, to build career, build a good profile, and also enhancing enhancing the discipline, and also developing the society and community in a greater sense. So this is my area of interest. I'm happy to collaborate to in not in more career sense, but in more professional interest. This is my professional area. I'm just as a volunteer work, especially research and publication, also consultancy. If people are interested, they can contact. I'm help to do also monitoring. This is my interest to help people, help the world, help the technologies to make the world better place. I have also a lot of work in this area, but I don't need to go all those things. So I think the time is probably running out. So I will stop my presentation here.
Thank you, sir, for the insightful presentation. And I'm sorry, the entire team, that because of some technical glitches, I couldn't log in the initial go. So now we are open into the question and answer session. So if there is any question and answer discussions, let's have it now. Yes, we have Sir Sunil Yadav here with the query. Yes, sir.
Yes, sir. My question is, sir, when you think the quantum computers will replace the classical computers of today? How much time frame visualize?
I think the most, to be pragmatic, the quantum computers may not replace classical computers as such in the near future, but they will operate both simultaneously. We'll use quantum computers in different places, but at the same time, classical computers will be also used in other areas. So in foreseeable time, both will exist.
All right, sir. Thank you. But can you give some idea about the cost of a quantum computer? I mean, the basic cost.
The quantum computers currently are not commercially available as such. Some places are, like in Canada, they have some quantum computers, but they are not really cannot do many things that we use our classical computers. And China also has introduced. They are also selling portable quantum computers commercially. In Shenzhen, somebody can buy, I saw on the internet, that can buy a quantum computers. A quantum computer can buy $8,000. But the rest of the world, quantum computers are not commercially available to buy from the shops and buy and sell. Cannot be bought and not very cheap. But in Australia, the currently government has given $1 billion for a company to develop a commercial quantum computers. So we are hoping another 4 or 5 years, this company in Australia will at least be able to produce commercially available quantum computers. And India government also, India also has this goal to produce, quantum commercial computers within India also.
Thank you, sir.
Yes, I think even Mr. Satish Simha is also here with a question. Yes, sir, you can proceed, sir.
Islam, good morning.
Hello, good morning.
Dr. Islam, my question is just to further what Colonel Sunil Yadav was asking. The interchangeability of algorithms between a basic computer and a quantum computer. Is it interchangeable? So, for example, if we write a algorithm which is solving some artificial intelligence issues on asset management, will that be directly taken into the quantum computers as well, or will it need some change?
It will need some changes, because what we do, the way we compute classical computers the same way the quantum computers don't operate. So the same algorithm cannot be used. So it has,
Yeah.
but we can use actually, say if we develop a quantum computing algorithm that can be actually simulated on classical computers. We can use classical computers to implement a quantum program, but it's not the other way around.
What I could understand is the quantum computing basically takes the analog methodology, and whereas the basic computers take the digital methodology.
Yes.
So the continuity of algorithms is more pronounced in case of quantum computers. That's what I could understand. Is that
Did
correct?
you say continuity?
The continuity of algorithm is more
Yes.
pronounced in case of a quantum computer than in case of a digital computer.
No, the approach is different because the programming approaches are different in classical computing and quantum computing. So they are not interchangeable. So that's the summary form. If we want to use classical computer, the program will be different. If we want to use a quantum computer or a classical computer can be also used to do quantum computing. So if it is the quantum inspired, then the algorithm, the approach should be different. Algorithm will be different and the coding will be also different.
Thank you, Dr. Sila.
Sir, another question actually. Do you think we'll be able to build some kind of digital to analog converters who will be, able to convert the programs from your classical computer and which can be given as an input to a quantum computer in future, say maybe 5 years from today, so that they can work together, not in tandem, no?
No, that is possible. But I mean, there are even currently there are some artificial intelligence programs, that we can still use. Suppose if we have there are programs, somebody once can send me an email. There are computer programs that can be used to convert a classical computing program to a quantum computing program by using artificial intelligence, generative artificial intelligence. It can be transferred, but it may not operate 100%, but we may have to do some modification and so on. But this there are different programs, artificial intelligence, ChatGPT type of programs are available that can convert one computing programs into another one. That's possible to do.
Okay. Thank you.
Yes, thank you, sir.
Yeah.
And I think here, yes, Mr. Amit Kapoor has also a question raised here. Yes, sir, you can proceed, sir.
So, well, one very basic question from asset management perspective, which type of computer is easier to maintain, the quantum or the digital?
I mean, if somebody it depends on the skill, they have like hardware, software, because quantum computing is quite involved. But we are simply, classical computers, we know, we are using, everybody knows how to use it. So simple, if somebody, because asset management traditionally, many places is still not very digitalized, not very to the highest level. So the first step is to use artificial intelligence and machine learning very extensively to automate it, fully automate. And and that can be done using our current computers easily, conveniently, if somebody knows the programming, especially embedded programming, and that can be done, and that has many benefits. But if we want to go beyond that, then somebody has to learn quantum computing, quantum programming, and then quantum hardware can be used to do programming, and then we can develop different quantum artificial intelligence or quantum machine learning programs that can be embedded in asset management. So it depends on the expertise of people or interest or available resources. But the main thing is it's better to digitalize asset management as much as possible, because that will give a lot of benefit in terms of time, in terms of flexibility, operation and efficiency and so on.
So my question was with respect to the computer itself, whether quantum computers as an asset are more difficult to maintain than the conventional computers or no?
I mean, maintaining quantum computers.
Yes, as an asset itself.
Okay, that's interesting. Quantum computers are certainly 1,000 times more difficult to maintain.
Okay, so you need more asset management, more serious asset management into maintaining the quantum computers.
Yeah, that's for sure. There is no doubt of that. And the whole quantum community is struggling how to manage these quantum computers, that asset.
Thank you, sir. Thank you so much.
Yes, sir. Professor Islam, you just mentioned that China has a commercial quantum computer, maybe. But are they actually doing engineering asset management? Because what I'm seeing is that quantum computing is more used in some of the portfolio financial asset management rather than engineering asset management. Because as you just also mentioned that a lot of digitalization has to take place before you actually go in for quantum computing. And I think most organizations haven't yet reached, especially engineering, they haven't yet reached that stage where all their assets are, digitalized. Most importantly, I think some of the friction data, which is, fundamental to any maintenance asset management activity. So that is a different kind of a challenge. So I'm not going into that, but I'm just asking a question regarding the computer that, or the quantum computer that China has made. Is it actually for engineering asset management, or is it some kind of a portfolio asset management, the finance side of thing, which is quite, today a lot of AI, ML are there in the financial applications.
If the quantum computers can actually I'll go to later on the China computing, but generally quantum computers are not being used only for portfolio management. Quantum computers can be and are being applied for all many other activities, including, especially some of the different areas are chemistry, engineering, chemistry, and also health, like cancer research, drug production. So quantum computing currently being used extensively many different areas, not only finance. The second question, I don't know what their quantum computers can do, what are their capabilities, but I have seen only on the internet. But if it is a good quantum computers, then it can be used also for asset management.
Okay, thank you. Professor Mishra?
Thank you, sir. I think we have one more question raised by Mr. Hare Krishna Mishra. Sir, are you?
Yeah, it is muted. Yeah. Am I audible now?
Yes,
yeah.
Yes, you are audible, sir.
Good afternoon. This is regarding the asset management perspective. If you look at the classical computing that is going on now, we are into cloud computing, platform as a service, software as a service and DevOps. How do you see the convergence between quantum computing with platform as a service, software as a service, and DevOps? And how can we take it forward?
But some of the cloud computing services can be also utilized through quantum computing. Because now currently the IBM computer, Google, they also some of these services they are also giving through cloud as a as a software as a service and so on. So that area is possible.
Yeah, that's okay. But what I'm saying is that as an asset management perspective,
yes,
if the data warehousing is already there in place in a cloud environment, yes, and your platform as a service is already embedded into that, how does it matter whether this is quantum computing or soft computing, classical computing? Will it change?
Yeah, certainly, because the programs, like codings, the integration, these have to be done in new way.
So in that case, total cost of ownership will change, right?
The total cost may change, but that will give also benefit, especially in the long-term benefits, advancement for other form of many in terms of better prediction, better maintenance, more cost saving, and can also more data processing, data streaming. There are benefits, there are costs, and if we, I have not done a real project to tell you that I have not done a real project in quantum computing in asset management.
Well said, sir. In fact, we are looking forward for a use case. At least we could have seen that here. But thank you very much for introducing the concepts here.
Yes.
Thank you, sir. So, are there any more questions? So that if not, then we can move on to the next part of the session. Okay. Thank you for the insightful discussion and the question and answer. I now invite Mr. Satish Simha, former Chief General Manager of BEML and esteemed life member of the Asset Management Society, to extend the vote of thanks.
Thank you. Thank you, please.
Yes, yes, sir.
Ladies and gentlemen, good afternoon. Distinguished guests, speaker, and participants, I stand before you today with immense gratitude and a heart full of appreciation for Dr. Islam. This webinar has been an enlightening experience, and I would like to extend my sincere thanks to everyone who have made it possible. At the outset, I convey my gratitude to the Master of Ceremony for having convened the event successfully. Thank you, ma'am. I would like to extend my deepest gratitude to our esteemed speaker, Professor Sardar M.N. Islam. His insights, knowledge, and expertise has enriched our understanding. First and foremost, we came to know there is something called quantum computing, which can use in our day-to-day lives. Thank you for enlightening us, sir. Thank you for sharing your valuable time and wisdom with us. I'd like to extend my gratitude to Professor Raghuveer Pai, Colonel Sunil Yadav, Sir Amit Kapoor, and all dignitaries and eminent personalities who have graced this occasion by their presence. I extend my sincere thanks to the organizing committee, the technical committee who have tirelessly worked for the seamless execution of this webinar. Thanks to the sponsors, the partners, and the media. Their support and collaboration has made this webinar possible. Thank you all once again for believing in our vision and contributing to its success. Thank you, please.
Thank you, Mr. Satish Simha, for doing the honors today, vote of thanks. And thank you, Professor Islam, on behalf of my personal behalf, as well as AMSI and all of us here. Thank you.
Thank you, everybody.
Thank you.
I'm very happy to meet you, all of you. Hope to see you sometime in Melbourne, Australia.
Yeah.
Welcome.
Thank you.
Thank you.
Thank you.
Thank you. Thank you, everybody. Thank you.
Thank you.